Okay, so now we'll start with machine learning. In this section, you will get an introduction to machine learning, and we'll talk about introduction to machine learning, types of machine learning and their types, and we'll see some cool applications, and then we will see some problem of overfitting and underfitting, and then we'll wrap up this section. Okay, so let's start. Okay, so now we'll answer a question: what is machine learning? And you may ask, hey Ayush, it's very can you tell what actually machine learning is? Yeah, you will get to know more and more about what actually the big picture of machine learning means in depth when we will go through this course. But in simple terms, machine learning is like this: computer programs that uses algorithms to analyze the data and make intelligent predictions based on the data without being explicitly programmed. And you might think, hey Ayush, what is kind of this? I'm getting a little bit confused. No worries. So let's get into this, and let me explain you what I'm saying over here on this blackboard. So you are given a data, okay, and then you give to the algorithm. The algorithm analyzes the data, and whatever he has analyzed or learned from the data, it makes predictions based onto that. Okay, so specifically what we are doing, we want to make a function x that maps out input variable x to the output variable y. And you may think, here you sure confusing me, what is x, what is y? No worries. X is the input feature. Means let's take in a problem statement of predicting the house prices. Okay, so you wanted to do this. So here, on the basis of the size of the house, you wanted to predict the price of the house. Okay, so you give input variable x and you get output variable y. Okay, so on the basis of the size of the house, you want the price of the house. Okay, so you wanted to make a function. F that takes input x and maps that to y. And that's the definition of machine learning. That's the beauty of machine learning. So what we were doing, we want to map our input variable x. Maybe it can be maybe the size of the house, maybe the number of fans in the house, maybe the number of bedrooms in the house. So I'm denoting with a subscript 1, subscript 2, subscript 3, and we want to make a function that maps these input variables to the output variable, which we denote with y, which is the price of the house. And that we are doing, and we will learn how to make these functions. Okay, so that's the beauty of machine learning, which you can see over here. So let's see some of the more formal definitions which you will see more over the internet. Now, the machine learning is the field of study that gives computer the ability to learn without being explicitly programmed, said by Arthur Samuel. But one definition that I've said to you is totally means if someone asks you, hey, whatever your name, what is machine learning? You just ask, hey, I know a better way to define a machine learning. You just make a function that maps your input variables to the output variable. Okay, and that's the beauty, or that's called the machine learning. And I hope that you got it, what I'm trying to say you here. And X's are the input features that you wanted to, on the basis of that, these are the input features, and on the basis of that you want to predict the price. Okay, another definition of machine learning is the computer program is said to learn from the experience E with respect to the some class of a task T and some performance measured by P. If its performance on T as measured by P improves with the experience E. And this seems a little bit intimidating, but let me clear this definition. It's very my favorite definition, although this is my favorite definition that I've shown to you, but let me tell you what the definition tells you. The definition is, so before that, let me take one example, which is let's take an example of checkers. Okay, playing checkers. playing checkers. I hope that you no. Let's take another, because many other people do not play checkers over here. Okay, so let's take a spam email spam detection system. Email spam detection system, which you will make in this course. Yeah, you will make this course. You will make this into the course. Okay, so this is a problem statement, and what's the let's fit that definition onto this problem. Here, T is the detecting the emails, means detecting whether the email is a spam or a not. So let's denote 0 as detecting a spam, or 1 as ham. Okay, so let's say ham. And E is the experience of his prediction, is the experience. Here E is the experience of detection, and P is the performance, how much performance increases upon to the experience. So in this way, higher the experience is, best the system is. But I think this is more formally fit to something called a reinforcement learning, which will not see the advanced learning, but again, the definition which you have to take is you wanted to make a function f that maps your input variables to the output variable, and that's machine learning, and or you can say that's the beauty of machine learning. Okay, so some of the applications of machine learning, there is I've just listed on few, but there are a lot more. Self-driving cars, real estate, stock price prediction. In medical, we have a COVID-19 detection, maybe using chest radiographs, and then disease prediction, cancer detection, etc. And then it's just a boom, and I highly encourage people to get into this field and try to contribute to the world in a unique way. Okay, so you can see over here some of the applications of machine learning. So how it works. So what you do, let me get back to my board and how it actually works. All this, how it works. It's kind of very easy. How it works. First, you study a problem. So again, let's take a problem. Let's take a problem of again a spam detection. A spam detection system. Okay, I think this is C. Okay, so you have to make a spam detection system. So first you study the problem, you have a look at the data, how actual the data is. Okay, so first you do this. The second thing, this is a basic workflow. The second thing, you train the algorithm, and algorithm is just a function. It's just a function. Okay, f of x, which you will how it is defined, which you'll see later on. But you just have a function which is algorithm. This is the algorithm, and you train with this algorithm, and then you go further into evaluation. You evaluate it into you give new emails and check whether it's correct or not, and then if it is good, then you launch the system. Otherwise you analyze some error, you do error analysis, and then you go further into tuning improving your algorithm, or evaluating your and then you evaluate, then again do like this. So that's why machine learning is called ML, is very iterative process, which you will see in ML Oops why it is termed that. But if beginner, don't worry about it. Okay, but if you want to get it after this course, you can get to my GANs course, or maybe the deep learning course, or maybe another course which is DSA, which I'll talk about why it is very important, and then you can head over to the ML Oops videos. Okay, so this is the basic. You can head over to that and learn something new from there. Okay, so what are the types of machine learning systems? Since there are, I think, three types of the main machine learning systems are three types: supervised, unsupervised, reinforcement learning. And although there is few more, which is batch learning, transfer learning, active learning, passive learning, and etc., which you can learn obviously. When you go further, means into more into machine learning, then you will see that how you're learning these all, and you learn to grasp each and every concept in a few minutes. Okay, so what is supervised learning? Supervised learning, let's go get back to my board again, and let's take an example of another example, which is my favorite. Not my favorite, but yeah, it's house price prediction. So I'm just writing it out: house price prediction system. Okay, so this is a house price prediction. So you have a feature. Let's denote that on the basis of the size of the house. I'm just taking example because in the real world, the size of the house, the number of fans in the house, number of bedrooms in the house, on the basis of, but just for now, for predicting this from the size of the house, you want to predict the price of the house. You want to predict the price of the house, which we denote as a y, and whatever we take as a feature, we denote this as a x. Okay, so there is we denote there is only one feature, which is x1, and only we are getting a one output, which is y. Okay, so we provide x1 means the size of the house, and we are getting the price of the house as an output. Okay, so you can see over here that we have size and we have a labeled, means we have given the price, and the model can learn from this how the trend is on a, it can recognize patterns. Okay, so you can see over here that our data is labeled as a y, means we know what our output, so it learned from their label and input. That's called a supervised learning. How you can identify the problem is supervised, because you see the target variable, which is called the target. This is called the target variable, and this is called features or variables. Okay, and the one we want to predict is called the target variable. So this is the features or variable. So you see that there is a relationship between your input value x and the output value y. Input value x and output value y. Why I'm saying it has some relationship, because you can see over that we are given the size of the house and we want to predict the price of house. So you can see over the entities that they have some kind of relationship, and we know what our output should look like. In this case, we know what our output should look like in regression. It's kind of a continuous output. Our output will be in continuous value, so we know what our output should look like, and that's called supervised learning. Okay, so I think I think it's going good, means you're understanding what I'm saying. So in simple terms, you can see the definition over here. We feed the data, and the data are labeled, means that the output variable, which we denote as a y, are labeled, and which has some relationship between our input value x and the output value y. Okay, so in unsupervised learning, which I'm not going to go dig dive just now, and further I will be digging dive into this. So the data are not labeled, and we can say that we don't know what our output should look like, and there is not kind of any relationship between what will be our input variable and what will be our output variable, and we have to recognize our patterns based on the data. For doing so, we have different algorithm which we'll study later. Okay, so I'm just not digging deep, but in simple terms, what I'm saying that. Let me tell you what I'm saying. Okay, so let's say these are the t-shirt sizing. You have a different t-shirts. I'm denoting this as t-shirt, so we have a different t-shirt, and and this is our data. And you have to simply classify or cluster it out. So what your model will do, it simply make this as a L, it simply makes this as a XL, and it simply makes as a M. Okay, so it's just make clusters. It makes cluster XL and L. And for now, I don't recommend brainstorming these things, because we will first we have to understand fully supervised learning, then it will much clear unsupervised learning. So I don't want to dive into unsupervised learning for now, but you can see over the definitions are cut to cut. Okay, so let's keep deep diving into supervised learning. So what are supervised learning? So in supervised learning, we know our output variable and input variable, etc. that I will just explain you over house price prediction. So in supervised learning, we have two types of problems. The problems of supervised learning can be classified into two types. So let me write it. A supervised learning problem can be classified into regression problem, and it can be classified into classification problem. Okay, so let's keep talking about what is regression, what is classification. So I'm going to take one example, which is a house price prediction, and we can see over here that our output will be in continuous value, because supervised learning, and we know what our output is. So you can see over that output will be in continuous value. Okay, so your output is in continuous value. And in classification, let's say given a picture X, means the often you want to classify an image of a picture as a cat or a non-cat, Okay, so you given a picture X, you wanted to identify that as a cat or non-cat. Okay, so you can see over that is a binary. It is only two. It is called a discrete value. It is called the discrete value. Means we can now classify that in regression, if our output of that problem is in continuous value, that is a regression problem. If our output of the particular problem is in discrete value, we can classify that as a classification problem. And you can see over here the definition is the same. Okay, so why we need to divide our data? So let me talk about, because I'm talking too much about data, but what is data? This question arises, a very good question that I want to ask by myself. Is data, how does data looks like? In data, let's take an example of an application system that is a price of the house, house price predictor. Okay, so the data will look like this. So I'm just making a data frame. So you have a size of the house, then you have a number of fans, then you have a number of bedrooms, then is the target variable, which is the price. So these are your X, and this is your Y. Okay, and what you do, let's take 9 square feet to 22. I'm just taking as a 1,000, etc. Just $1,000. I'm just taking as an example. Don't think that is a 9 square feet size of the house. Don't think like that. Okay, so this is kind of thing. So this is kind of thing, and we have a size, and we have a number of fans, we have a number of bedrooms. Okay, so what you do here, you can see over here that we have your data, and what you do, you divide your data into training and testing set. Training and testing set. So let's say you have 100% of data. You take 80% of your data for training or model and 20% of your data for testing. The reason why you take this to evaluate your model, because from where you will get all those for testing. So you just keep 20% for evaluating to check how best your model is. Okay, so this is the division of a data, which we'll see more later on. Okay, so there are two problems that I want to highlight is overfitting and underfitting. Okay, so what is overfitting? So let's take an example again. I just believe in examples. Okay, so here is your X and Y plane. I hope that everyone remembers in their school days. Oops, what happens? I hope that I drawn correctly. Okay, so you have these features. Let me draw it very quick way. This is your data points, and what you do, you simply draw a straight line. To make predictions. Okay, so this is your input, which is X. So let's say 2200 square feet. So it will go over here and check what is the price. So it will give here. Okay, so like that it will make prediction, which we'll see later on. So you can see over here that in underfitting, what happens? If your model has not performed well onto the training data as well as on testing data, means in underfitting your model does not perform well onto the training and the testing data, means your model performs bad on the training and the testing data. It means because you don't have a large number of data, you can simply add more data. Okay. But what happens in underfitting? Can anyone tell me what happens in underfitting? So let me highlight this little bit. So in underfitting, if your model has learned too much, this is because when you have too much of features. So let's say it will try to touch each and every point. And this is. And you can see if your model learned too much and it is generalizing very well onto the training data, on the training data, but it fails to generalize well on testing data, then you can say that your model is overfitting. Okay, so you can see over here that diagram is over here, and you can see over here that underfitting, which does not fit a straight line in a very good way, and good fit is good model. You can just fit a straight line, and the bad fit overfitted. Okay, so the solutions of this, which we'll see later on, but before that we'll touch some algorithms, and again some notations which I've already taught you. X means the input features, x1 x2 all the way down to the xn. Y means the output features. M means the number of training examples, and here let's say 600 is training example, which we will get to know more further, which when we will go more further into this course. Okay, so now we are done with this introduction of machine learning, and I really hope that you enjoyed this tutorial. And in the next section we'll be talking about one of the algorithm, which is linear regression, and I hope that you will really enjoy that. So let's meet at the next section.